I'm here with Andrew Whitesell from Beaumont Design in the States, and we're going to talk about his project, the Fecal Sludge Omni-Ingestor. My first question is, what makes this project stand out from the rest, or what's unique about it?
So I would say, compared to the other the grantees that are here, we're not developing toilet technology. We're the only ones that are developing, well, there's a few others, but we're developing means of removing waste from septic tanks and latrine pits and improving the efficiency of transporting it to a dump site on a big scale. So we're not trying to compete with the rammer. We're trying to compete with vacuum truck operators, really.
And what are your achievements so far? How successful has it been, your research or your development?
It's been pretty successful. We've developed fairly unique pumping systems. They're really optimized for what we're trying to achieve. So low cost, durability, the ability to pump 40% solid waste, the ability to reach 50 meters and more into the settlements. So we've done some studies. We can reach over 92% of all the vaults in Africa from the nearest road. With a 100-meter hose, we can reach 97% of all the vaults in Africa. So from a pumping perspective, we've achieved everything we want to achieve. So.
And what have been the difficulties and challenges that you have faced up until now?
The biggest challenge is still being able to dewater the sludge. So we've successfully developed dewatering systems that have been tested in the US, but you're dealing with a very consistent type of sludge. So the fear is that once we go into the field where you're dealing with 2 cubic meters here and 2 cubic meters there, and different chemistry in the pits and different materials in the pits, that our dewatering systems won't be robust enough. So what we're doing next is a very focused effort just on dewatering systems.
The dewatering is meant to take place at the site of where you take it out directly there.
Right, and we're trying to do dewatering. So we do detrash, degrit, so rocks, glass, metal, sand, and sludge thickening. It's probably dewatering is not really appropriate. We were only trying to get to about 10% solids. And then we need to treat all of those streams that are coming out. So we have to treat the trash, treat the grit, make it safe so that we can leave it on site, treat the water, clarify the water, deodorize the water, so that we can leave that on site and make it conform to WHO guidelines.
And where are you at in terms of rolling this out at a large scale onto the market? What's the technology readiness level?
I don't use the TRL very often. From a product development standpoint, we're entering domestic field testing in about 6 weeks. We've already done some field testing in Nairobi and in the States, but this will be the really focused field testing where we're actually giving the equipment over to a company that empties pits and letting them hammer on the equipment. So that'll start in about 6 weeks. It'll run 6 to 7 months. At the end of that, we'll know what improvements need to be made, what changes, and then we'll begin foreign field testing. So foreign field testing should begin early 2015, and that could last 4 months, it could last 8, 9 months, really depends on how successful the testing is.
So domestic field testing means in the States?
Yes.
Okay.
Yes. So commercialization of the pumping system will start in 2015. Mm-hmm. The mobile preprocessor, the goal is to begin commercialization in 2016.
Mm-hmm. Great. Thank you very much.
Sure. Thanks.